Okay, good morning, good afternoon, good evening. Welcome back to our tutorials as we prepare for the upcoming exam in supplementary exams. So today I want to focus all differentiation questions in the deferred paper. We're all questions which talks about differentiating something in the deferred paper for 2025. So all differentiation questions in the deferred paper. I'm sure I've just spotted out a number of them. So if you look at all those questions in the deferred paper, you'll be able to see that those are the questions which I've just dotted down on the board. So the first one says differentiate the following functions. So we're going to differentiate the following functions. And then the second one, we're going to use logarithmic differentiation to differentiate that. So I want us to pay particular attention to how we're going to differentiate each and every function there. Now, we have to understand that when it comes to differentiation, always be able to recall some of the properties and some of the rules. Be able to identify it. So once you see a certain question, at least something need to click within your mind to say, I think at this particular point, I'm able to use this particular rule. Is it product rule? Is it quotient rule? Is it chain rule? And so forth. Yeah, so let's start with the first one. We want to differentiate. So now we have to understand that differentiating is the same as finding the derivative, and it's the same as finding dy dx. It's still the same question. So they can ask you to say find dy dx, they can tell you to say find the derivative, they can tell you to say find the differentiation or differentiate the function. So we'll start with the first one. My board is very small, but we'll be able to manage it. So the first one says that f of x is equals to the root of x multiplied by the natural log of 3x. So we want to differentiate this function. Now, when we differentiate this function, what we're going to end up with is what is known as f prime of x. So note that if f of x is differentiated, we have a new function called f prime of x. That's what you have to take note of. So that is just basically a starter for now, which you have to understand. So if we differentiate this, the new function we're going to have will be f prime of x. Now, let's pay particular attention to what we have. So f of x is made up of what? The root of x multiplied by the natural log of 3x. So if this is what you have, if you have a function which is a product of two functions, then here we are going to use the product rule. We shall use the product rule. So product rule is a rule which is used once you see that a given function is simply a multiplication of basically two functions. So if you can see here, this is a function of x and this is also a function of x. So basically, if you look at f of x is more like in the form of u multiplied by v, where u and v are both functions of x. So if this is the kind of function I have, then f prime of x, which is the derivative, should be equal to, you differentiate the first function becoming u prime multiplied by the second function, which is a v, plus differentiate the second function, which is v prime multiplied by the first function, which is a u. This is the formula for the product rule. We are okay? So now in this case, u is basically root x. V is basically the natural log of 3x. So what am I going to find? What am I going to do? I need to find my u prime and my v prime. So we are going to have u is equals to the root of x. So if I want to find u prime, it means I have to differentiate this guy. Well, okay. So now take note that the root of x can still be written as x power 1 over 2. It's still the same thing. So now differentiating this guy, what am I going to have? The power rule states that the power drops down. So it means I'm going to have 1 over 2. This x raised to power 1 over 2, but this power decreases by 1. Minus 1, according to the power rule. So if you are differentiating any function, any polynomial function, what happens is that this power drops down, the same power decreases by 1. So 1 over 2 dropped down, 1 over 2 decreased by 1, it means minus a 1. Implying that u prime this time around is now going to be equals to 1 over 2 x, 1 over 2 minus 1 is basically negative 1 over 2. This is my u prime. We're okay? Then next we go to v. V is basically the natural log of 3x. This is my v. I have to differentiate v. If I differentiate v, I'm going to have v prime. Now the question comes in, once you see a natural log, how do you differentiate a natural log? How do you differentiate a natural log? So basically here, what am I going to have? I'm going to have natural log of 3x. How do you differentiate it? We always focus on what is inside. So according to derivative of natural logs, if I have whatsoever is inside, so our focus is you look at what is inside, you differentiate the inside part. So the derivative of the inside will be on the numerator over the actual itself, 3x. So derivative of the inside is basically a 3. So now, what do I mean by that statement? What do I mean? What we're simply saying is that, let me take note. So take note of this. What I'm trying to indicate here is that if I have, let's say, y to be equals to the natural log of, in the bracket, inside the log here, there is a certain function. Let's call this function to be u. So what we are simply saying that y prime, if we differentiate this, y prime will be equals to the derivative of the inside guy, which will be u prime, over the actual u itself. That's what we mean. So in this case, we have natural log of 3x. So we differentiate the inside guy, derivative of the 3x. This is power 1 here. 1 drops down, it will still be 3 times 1. 1 minus 1. 1 minus 1 is a 0. X power 0 is 1. No wonder we just have a 3 on the numerator here. So 3 over 3x, so that v prime becomes 3 goes becomes 1 over x as our v prime. So if we see what has happened here, according to this f of x, which was a product of two functions, function u and function v, these two which were a product, we know that f prime of x can only be found by u prime multiplied by v plus v prime multiplied by u. We have found our u, we know our u prime, we know our v, we know our v prime. Grab all these, put them in that formula and simplify. That is your answer. So now let's put them in the formula and simplify. So I'll delete this part. Yeah. Okay, let me just try to jot down my values then. So we have our u is equals to x power 1 over 2. We have our u prime to be equals to 1 over 2 x power negative 1 over 2. And we have our v to be equals to the natural log of 3x. And we have our v prime to be equals to 1 over x. Now let's replace everything in the formula. So what am I going to have? F prime of x will be equals to u prime. It is this guy. So I'm going to have 1 over 2 x power negative 1 over 2 multiplied by v which is a multiplication of natural log of 3x, plus v prime is 1 over x multiplied by u, which is x power 1 over 2. The rest is just basically simplifying things. Now, let's put positive indices here somewhere. This is x power negative 1. It can come in the denominator. It means I'm going to have this times that, the natural log of 3x on top over 2x power positive 1 over 2. This side I'm going to have plus. Am I correct? Yeah. This side I'm going to have plus. This is positive index already, so x power 1 over 2 divided by x. As simple as that. If you wish to, obviously, this can be simplified further by x power 1 over 2 divided by x. That is something like what? X power 5. Even just here, it's still okay. At least it still makes sense. Something like that. So, that is the derivative of f of x equals to the root of x multiplied by natural log of 3x. As simple as that. We are okay. Let's go to the second one. So we are now on the second part. So the second part, we want to differentiate f of x to be equals to the natural log of x squared over x squared plus 5. Remember what we said under derivative of natural logs. Now, every time you say a log, remember how to differentiate natural logs, but at the same time, at least be able to recall some properties on logs. Because once you recall some properties of logs, it will be very much easy to simplify a log so that you don't have any difficulties with it. So, what do I have here? Remember that if y is equals to the natural log of u, then y prime is equals to u prime over u. So this, for me to find f prime of x, obviously we have to differentiate the inside divided by the actual cell of each side. But that will be a lengthy process. It will be very complex because of what you have. For you to differentiate this to be quotient true, shiny, and then be divided by itself, it will be something like complex. So what do? Simplify things for yourself here by using log properties. We know that the natural log of a over b is basically equal to the natural log of a minus the natural log of b. Remember that? So this is what is in the form of that. This over that. If it was a multiplication, it would have been, if it was a times b, it could have been a plus natural log of b. But this is a division. So we're going to use the property of division principle on logs. So it means this can be written as f of x to be equals to the natural log of x squared minus the natural log of x squared plus 5. Things become simple from there. Then what am I going to have next? According to the power rule, if I wish, I can bring it down as a constant, which is very much simple. So it means f of x can be equals to 2 natural log of x minus the natural log of x squared plus 5. Now, from there, let's now differentiate. F prime of x can now be equals to, this is a constant, it will still maintain. Natural log of x, let's differentiate natural log of x. The 2 was maintained because it's a constant. We are now just concentrating on the function of x here. So the function of x, how do you differentiate natural log? You differentiate the inside over the actual itself. So the inside is x. Differentiating x, what do you have? Take a 1 minute chew pill, differentiate x. What is happening? The derivative of x is basically a 1 over the actual self itself of x. So this is what I'm going to have with the first term. The second term here, this will be a minus. Differentiate the inside part. The 2 drops down to be 2x, 2 minus 1 to the power 1. Derivative of a constant is always a what? 0 over x squared plus 5. Simplify. F prime of x will now be equals to this over that, which is 2 over x minus 2x over x squared plus 5. If you wish to, you can simplify as a single fraction. F prime of x now be equals to f prime of x now will be equals to x open bracket x squared plus 5. This into this goes, this times that to be 2x squared plus 5. This goes, this times that minus 2x squared. We are okay? After finding the f prime of x, now I'm trying to simplify as a single fraction. That's what we're trying to do there. So trying to simplify the single fraction, then lowest common denominator between x and x squared plus 5. That's guy, this into this, that, and blah blah. I'm sure that's grade 1 method. And then from there, simplify the numerator. I'm going to have f prime of x to be equals to, this will be 2x squared plus 10 minus 2x squared over x squared plus 5. So that we can have f prime of x, this and this goes, they are like terms. 2x squared minus 2x squared is a 0. So that we can have 10 over x squared plus 5 as the final answer. We are okay? Yeah. Let's shift to the third one. Third one. Let's look at the third one. So the third one is this guy. We're differentiating y to be equals to the root of t open bracket 3 minus t squared. Differentiating that guy. How do we differentiate that guy? So now here, be careful. We are used with my variables x throughout, but in this case, our independent variable is not x. So pay particular attention to what you're differentiating with respect to. So here it's with respect to t, not x. So when we differentiate this, we're going to have y prime. And a function of t, this is product rule. This is function 1, this is function 2. This is u, this is v. So we can say let u be equals to root t and let v be equals to 3 minus t squared. So that u prime can be equals to, this is the same as, remember, root of t can be written as t power 1 over 2. So that when you are differentiating it, the power drops down 1 over 2, t power negative 1 over 2. We are okay? I'm sure at this stage we are okay. Because 1 over 2 minus 1 is basically negative 1 over 2. 1 over 2 minus 1 is basically negative 1 over 2. So 1 over 2 multiplied by t power negative 1 over 2. This is what I'm going to have. And then v prime is equal to, derivative of a constant is 0. Derivative of this will be negative. 2 drops down. T, 2 minus 1 is 1. So we're going to have negative 2t. Then let's replace. Y prime should be equals to u multiplied by v prime plus u prime multiplied by v plus v prime multiplied by u, something like that. So that is our product rule. Differentiate the first function minus the So let's replace. Y prime is equals to 1 over 2. Now the thing is, I hate my negative exponent. So this is negative 1 over 2. It can be taken down in the denominator, isn't it? So this can be written as 1 over 2. It joins with t power positive 1 over 2 as a positive index. As a positive index. Because it was negative here, it can come in the denominator. So this is our u prime. V is basically 3 minus t squared plus v prime is basically negative 2 plus this times this positive becomes a negative 2t. And then u is basically root of t. Root of t, or if you wish to, you can write it as t power 1 over 2. So that this can be simplified further by saying 1 over 2 t power 1 over 2 multiplied by 3 minus t squared. This is more like same bases by different powers. We can add the 2 so that we can have negative 2 t power 3 over 2. As simple as that. And if you wish to, you can simplify as a single fraction, but it's still the same the way it is. You are done. And you are done with the third one. The rest is just basically you simplifying it. Sometimes they can say, no, show that this is equals to that thing. So for what to show whatsoever expression has been given to you, all you have to do is just basically simplify that to suit whatsoever was given. There are such questions where they already give you the answer to that show that the derivative of this is equals to maybe this, or maybe it's equals to something simplified other than this. So just have to simplify that. Sometimes maybe a single fraction, something like that. As simple as that. But if it is not that, just ending there is still okay. You are very much safe. Alright, let's look at the last one. Use logarithmic differentiation. Now, we're using logarithmic differentiation. That's another method of differentiating functions. So, you can differentiate this function, just quite right in with other methods. But, here you've been restricted to use logarithmic differentiation. Now, from the word logarithmic, it means we are applying logs somehow. So, how do you do when it says use logarithmic differentiation? What does it mean when they say use logarithmic differentiation? So now look at this. My function is y equals to 2x power 4x e power x squared. First step, apply natural log on both sides of the function. So we are applying natural log on both sides of the function. So this means I'm going to have natural log of y to be equals to the natural log of 2x 4x e x squared. That's the first step. Apply natural log on both sides. Second step, what am I going to do? Simplify things. What do I mean by simplifying things? Simplify it in terms of logarithmic way. Obviously, this is already a simplified version. This would be natural log of y. This is a product inside. It can be broken down to natural log of 2x power 4x natural log of what? 2, this is a product, 2 times this is a product, plus natural log of this, which is x power 4x. There's a multiplication here, there's a multiplication here, plus natural log of e power x squared. Multiplication rule, if there's a times, it leads to a plus. I'm sure you can remember this property. Log of a times b, this leads to log a plus log b. This is what has happened here. This is 2 times this. So this will be natural log of 2 plus natural log of x power 4x plus natural log of e power x squared from this property. We are okay? Yeah. So from there, what am I going to do? We can use some power rules. So this will be natural log of y to be equals to the natural log of 2 plus the 4x is a power, it can drop down, becomes 4x, natural log of x, plus x squared is a power, it can come down, becomes x squared, natural log of e is what? 1. Okay, let me write it. Perfect your steps. Natural log of e. Now remember that natural log of e is 1. This guy is a 1. ln of e is always a 1 because this is a log of base e and then the input we have e. So this is basically a 1. So by the end of the night, what you're going to have is the natural log of y to be equal to natural log of 2 plus 4x natural log of x plus x squared, because 1 times x squared is x squared. So when you're using logarithmic differentiation, first step, apply logs on both sides. Simplify. Then after that, we have to differentiate implicitly. Differentiate implicitly. Differentiate implicitly. What do I mean? We'll differentiate everything but giving respect to x. We'll differentiate every variable but giving respect to x. So it means that if I differentiate the natural log of y, my answer should have dy dx attached to it. But if I differentiate the one which has a variable x by giving respect to it, so we won't attach dy dx to it. So we'll differentiate all the terms, starting with this guy, natural log of y. Remember, how do we differentiate natural logs? I've been preaching about this. If we have y equals to the natural log of u, then y prime is equals to u prime over u. Well, okay? So this is what we're going to do everywhere. So natural log of y means we're differentiating y. Derivative of y, we're taking it as a variable. So derivative of y power 1 drops down, 1 times 1 minus 1 is 0, so y power 0 is basically 1. So we have 1 on the numerator over the y itself. So natural log of y is basically 1 over y. But since it is implicit differentiation, we are going to multiply it by d dx or dy dx to be equal to, this is a constant. There is no variable here. There is no x, there is no y. The derivative of a constant is 0. So this is a 0. This is a variable x. There's x, and it's a product rule. 4x multiplied by natural log of x. So we are using product rule here. So what am I going to have? The derivative of 4x is basically 4 multiplied by the natural log of x plus derivative of natural log of x is 1 over x multiplied by 4x plus derivative of x squared, 2 drops down becomes 2x, something like that. Let's simplify everything. I'm going to have 1 over y multiplied by dy dx to be equals to 0 plus that will be 4 natural log of x plus this x and this x can go, so that I can have 4, am I correct? Yep, plus 2x. We are okay. Now this is the function we are going to have. Now the question is we want to find dy dx. So here we have to eliminate the 1 over y this side so that you can just remain dy dx on the left hand side. So what am I going to do? We are multiplying throughout. Multiply throughout. Multiply through by y. So that we can eliminate this, because 1 over y times y, it will cancel out, will just remain dy dx. But a y throughout. Well, okay. So deleting this part. So I'm going to have multiplying throughout by y. Y times this will remain with dy dx on the left hand side to be equals to 4 in x times y. We're going to have 4 multiplied by this y multiplied by the natural log of x plus 4 times this y, we're going to have 4y plus 2x times this y, we're going to have 2xy. Then things become simple. You're even done now. So the only last stage you can do here is replace back what is the value for y. Y in the first place was 2x 4x ex squared. So everywhere there is y now, we replace back with this guy. So it means my dy dx now will now be equals to 4 multiplied by 2x power 4x ex squared ln x plus 4 multiplied by 2x 4x ex squared plus 2x multiplied by 2x 4x ex squared, and you are done. As simple as drinking water. So those are the questions I spotted out in the deferred paper. Try to go through them, cement and understand every point, every statement. Try at least by all means to pause, rewind, and so forth. Thank you very much. See you in our next lesson.